Okay, Assalamualaikum and good day class. Masa ke?
Waalaikumsalam warahmatullahi wabarakatuh.
Ada yang tak puasa?
Puasa tu.
Ada.
Anda tahu.
Puasa tu.
Bagi dia ada kelas ke? Ni kelas first puasa ke ada kelas kedua ni? First class dalam bulan Ramadan.
First. Yes.
Okay, I have to do this class anyway. Puasa ke tak? Okay. Okay, last time I asked you to do example 5, right? Remember example 5?
Yes.
Okay, I asked
Yes.
you to do example 5 and most of you already uploaded the answer. As you realize, there is answer in your notes, but some of you, I'm not sure, you copy exactly or you did study and follow our method, because that answer is another method, but the answer will be the same. Okay, should be no problem. Hopefully you understand that. Okay, why I calling you for today? We have, okay, let me share my slide first. Okay, we back to basic. Back to our basic, okay. So, we know for one element or for one member, take this as example, the yellow one, you know where is near, where is far right. And at each node, we're gonna have displacement or degree of freedom, which means we're gonna have X and Y displacement on each node. So take this as an example. We number our node as here 1, 2, 3, 4. All right, if you realize in your nodes, for this one we have theta Y, and this one is theta X. So please be careful. This theta X from positive X axis, this one from positive Y axis. So you know what is your theta Y, what is theta X. And for that formula, for lambda Y is cos theta X, lambda Y is cos theta Y. And what you did learn, you find the coordinate for both points, then you should able to get lambda X and lambda Y, right? Beside that, siapa nak tanya tu?
Betul. Benda formula
Okay.
tu.
Alright, then you know you can use formula cos theta X also cos theta Y. Okay, without knowing near or far, like this one, you want to find stiffness metric for member K1 by using theta. So you take theta here, theta X and theta Y on this node. So numbering for your metric is 3, 4, 1, 2. So here 3, 4, 1, 2. Can you see that? So you take angle from here. This means 3, 4, 1, 2. That's numbering for this metric. So all of you can see that. Clear?
Okay.
Okay, so you're numbering 3, 4, 1, 2. Okay, then in some node, they didn't use theta X or theta Y, but they are using only theta. This theta taken from positive X axis. So here is theta. So for this one, if we take that theta, lambda x will be cos theta x, cos theta, or we can simplify as C. So we simplify that as C. So C is equal to lambda x or cos theta. Then for lambda y is sin theta, or we can write as S. Okay, when you refer in online, a lot of like, they're sometimes using S, sometimes using lambdas, M, L, and everything, but the principle still the same. So clear for this one, cos theta x and sin theta?
Yes.
Okay, then let's check. Take this as simple member. This is your x, this is your y. So if your theta x is 60, so your theta y is 30. So for lambda x, cos 60 is 0.5. Then for lambda y, cos 33 is 0.886. Or if you use theta, so lambda x cos 60 is, we will get 0.5. For lambda y sin 60, the same value for cos 30, 0.866. So still the same value, okay? Everybody clear on this?
Yeah.
Clear, all right, thank you. Then what I want you to do today is example 4, because we're not done yet on example 4. So go and see example 4. For this question given to you, angle 30, 30, and length for that is 5 meter on both sides, and then subjected to horizontal 5 kilonewton at point 1 to the right. So what you have to remember, always numbering unknown displacement first. So certainly join 1, we're going to start numbering from that. So 1, so 1, 2, then on the support, doesn't matter. Join 2 or join 3, 3, 4, 5, 6. So we know angle, so this angle here is 120. So using trigonometry, you know here is 30. So here is 30 degree. Now, we want to find stiffness metric for member 1. Okay, for member 1, listen carefully. We take theta 30 degree. This theta 30 degree on here. From joint number 2. Clear? Can you see that? From joint number 2 or point 2, we want to calculate stiffness metric K1. So here K1, using the formula, then numbering for your metric is 3, 4, 1, 2. So here 3, 4, 1, 2, 3, 4, 1, 2. Okay, for this step, you don't have to identify near or far. What you have to numbering, you have to consider is which one is unknown displacement, which one is known displacement. Clear for that?
Yeah.
Clear? Only what Hakim clear. I hopefully all of you understand that. Then we take for the same, still the same member, but you want to start your angle at joint 1. Right, joint 1. So here joint 1. So angle for that from positive x-axis is this angle. So that theta is 210 degree. Then numbering for that is 1, 2, 3, 4. So numbering for that K1 from join 1. So 1, 2, 3, 4, 1, 2, 3, 4. Can you see that, the difference? Everybody? Can you see that?
Yes. 1, 2, 3, 4.
Yeah. So that, be careful on that numbering.
Yeah.
That member
A
1
bit.
is theta 30 or theta 21. Then we go for member 2. So member 2 is here. So we want to take angle on joint 3. So from x axis positive to member 1, theta for that is 150. So theta 150. Then numbering for that metric will be 5612. So 5612. 5612. Right, clear? And also for member 2, you can use angle at joint 1. So if at joint 1, you should calculate this angle. So 210 plus 120. So that will be theta of 330 degree. And metric for that one is 1256. 1256. Everybody clear on that?
You depend by the angle, sir.
Yes,
It's
depend on
hard to-
angle. Then you calculate your theta from x positive. So this is your axis x, this is y. So if your member here, if your member on here, so this is theta from x positive, this angle, okay, from that your reference point. This one easier, not confusing between near and far. So clear? So that one,
Yeah.
330. Yeah, that's what I want to let you know. So later on, you done on example 5, right? By knowing the coordinate. Also, please try to do this with theta, with angle, okay? Then what I want you to do for this week, because I already released a work-based project. For that work-based project, you have to calculate and do calculation by using Excel. By using Excel, you can put formula. To do that, you can search in YouTube lot of references how to put the formula in Excel to solve those metrics. So later on, for this example form, each group try to do in Excel, then you have to post in Padlet. All right, is it clear?
Yes, sir.
Okay,
Clear, Doctor.
because for this one, you have to arrange properly in Excel. Later on, you're going to upgrade this example to your work-based project. Once you know how to operate for these 2 members, try to do with 5 members in example 5. Okay, now I want to share with you the example on Excel. All right, all of you can see this?
Cannot. Cannot, sir.
My Excel, tak nampak?
No, no.
Tak
Cannot.
boleh
Not.
nampak.
Tak nampak?
No.
Can see, sir, can see.
Can see, huh?
Nampak sir.
Nampak tak, sir?
Nampak.
Alright. Okay. This for example 4, I done on Excel. So it's up to you how to arrange, but this is my idea. You can put your information, then you calculate member 1, you know all the value, A, E, L, theta, and everything. It's up to you. You want to use C or S, lambda X or lambda Y. Then try to practice by using theta, okay? So once you done this set, for example, you done for member 1 here. This stiffness for member 1. In here, this metric, you know, right? Lambda X squared, lambda X, lambda Y, everything. You arrange in here, then you calculate for each single metric, for you get K1. So hopefully you know how to put a formula. Once you done on member 1, duplicate from member 1, do for member 2. But for member 2, we'll have different degree. So you done for member K2. Then if you have 5 members, you just copy here, member 2, member 3, and so on here. So then you done for member stiffness K1 and K2, you have to combine to get structure stiffness metric. All right, here is the tricky part. To learn to put this formula, you can Google it, a lot of information how to put formula to combine matrix 1 and matrix 2. Then automatically Excel can arrange this answer for you. All right, so you have to learn from Google. Lot of information, you just write stiffness matrix in Excel. Lot of example. What you have to do is, for example 4, when you done example 4, you do for example 5, okay? Then from here, you arrange in QKD. You know which part is K, QK, and you know which one is QU, and so on. If you can see on this red number is the displacement on that point, numbering. So be careful on this numbering because in Excel, they need that number to arrange this, and later on, you're going to calculate automatically and get the answer for displacement. So you're going to use this formula. Please learn in YouTube, a lot of example. Then you can get answer for displacement. When you get the answer for displacement, you need another formula to calculate how to find Q. All right. If you are using Windows, later on you will learn how to use Ctrl+Shift+Enter format to array your matrix. So once you're done for find the displacement and forces, you need to calculate internal forces. For internal forces, you need to use this formula. Do it in Excel. You know how to put formula. Then later on, you get the answer. All right, is it clear? Clear, everybody? Clear?
Yeah.
Boleh.
There's a negative. Must see it.
So later on, you study in group to solve problem 4 by using Excel. Then, once you done for example 4, try to change through the change coordinate or point for your reference. Try to set 1 and set 2 because, like I said before, if you take at point 1, numbering of what they call that, numbering of that metric will be different if you take at joint number 2 in example 4. Let me share this one. Alright, like this one. If you use member 1 for theta 30, so your numbering is 3412. If you are using here member 1 with theta 210, so your numbering for that is 1234, 1234. So once you done for that Excel, you can simply just change at any point and you will get the same answer. Similar with the structure stiffness metric. Alright, any question? That's what you have to do for this week. So for today, you have to do for problem 4. If you able to solve on the problem 4, try to do example 5, example 4 and example 5 for this week. Alright, any question?
So for the angle must for the as if for the cos and kalau sebelah kalau y as if ambil y.
Why?
Yes.
Yang mana?
Kalau yang tepi yang
Ini?
y.
Kalau yang y tu, kalau you pakai y theta, you kena ambil yang positif y ni. Positif y. So kalau you using theta, it's much easy for you if you just using theta. That is one, theta. One second, where? This one. Okay, that is one. This is your x, your y. Your x, your y. So your members here. For example, your member. So if you take theta, this theta, so that from positive x-axis. So that's your theta. And if you are using theta, for this one, you check here, lambda x is cos theta, lambda y is sin theta. Just using cos and sin. But if you are using cos theta y, that's for lambda. Lambda x is cos theta x, lambda y is cos theta y. Alright, is it clear?
Okay.
Okay, alright. Okay, everybody clear instruction for this week? So for today, try to do example 4, do it in Excel, try to play with that. You have to master some command, how to arrange and solve equation in matrix. So you can Google stiffness metric in Excel, in YouTube, lot of informations there. All right, clear? Okay, so I think it's clear. It's no more question. No more question, okay? No more question?
Yeah. No.
Okay, so try to do example 4. Later on, each of group, please share in Padlet. I want to check that. All right? Okay? Okay. If so, thank you very much. Assalamualaikum. Have a good day. Selamat berpuasa dan selamat buka puasa. Okay?
Thank you, Doktor. Doktor.
Okay. Bye. Assalamualaikum.
Doktor.
Apa dia?
Yang kerja ni hantar last bila?
Bila WhatsApp hantar lah. So, ini untuk for this week.
Oh, kira Jumaat ni kena hantar ke last week.
Tapi sebab awak ada 2 jam awak Jumaat, awak hantar lah.
Kalau hari Ahad boleh tak?
Ahad, kenapa Ahad? Nak pergi mana?
Tak, Jumaat kan? So, ini nak hantar macam
jadi SA je. SA dengan aku ada hari.
Hantar lah. At least saya nak tengok Excel awak possible boleh buat tak? SA Jumaat ni kan?
Yes.
Boleh.
Yeah.
SA apa dia? SA cable dan truss saja. Stiffness metric truss. Okay. Okay lah, you boleh hantar because this exercise for this week. Try lah as soon as possible, jangan lambat sangat. Okay.
Boleh.
Ada test ke? Pak Izzuddin ke ni, apa nama dia?
Yes.
Kenapa awak banyak test ke?
Kata macam apa hari Khamis ni ada apa ni? Statistik, hari Jumaat pula ada SA. So ingat macam dekat-dekat kan. So ingat nak minta masuk.
sebab ni subjek ni hari ni 2 jam, hari Khamis sejam kan. So at least you study problem 4 for today. Okay, study for problem 4 for today, try to do Excel. Okay?
Boleh Doktor.
Alright. Okay, Assalamualaikum. Have a good day.
Salam.
Okay, bye.